Okay guys, here is our video on the Unit 1 review packet for geometry. This is page number 2. Let's get started at the top. It says name the relationship complementary, linear, pair, vertical, or adjacent. Use all that apply. Well, if we look at number 15, we'll notice that we have this box that represents a right angle. Since this is 90 degrees, we know that this piece here also on top of this straight line will also be 90 degrees. Whenever two angles add up to 90 degrees, we call that complementary. And something funny we did, you'll notice up here that it says an I. This means to complement something. It should be an E. Complementary means it adds up to 90 degrees. These angles are also next to each other. We call that adjacent. So these are also a pair of adjacent angles. Okay, number 16. You'll notice we have a straight line. Whenever two angles fit on one side of a straight line right next to each other, we call that a linear pair. A linear pair always adds up to 180 degrees. It's supplementary. But a linear pair, by definition, also has to be adjacent. The two angles have to be next to each other. So we also use the word adjacent to describe this pair. In number 17, we have angles that are diagonal or across from each other. You'll notice they're formed by two straight lines intersecting. So A is between orange and yellow, B is between orange and yellow. That's a pair of vertical angles. Because they're not next to each other, A would have had to be here or here. They're across from each other like this. They're not adjacent. Number 18, suppose the coordinate of P is -4 and the length of PQ is 13. Remember, when there's no line on top, that means the length of PQ, the distance between P and Q. What are the possible coordinates of Q? Well, I'm going to start by drawing a line. P is at -4, and we know Q is 13 units away from P. So if I were to move this way 13, I would get to Q. But here's the thing, we don't know that it goes this direction. We also could go this direction to get to Q. And we'd also go 13 to go this direction. We want to figure out those coordinates. Well, if I start at P, which is -4, if I go backwards, I'm subtracting 13 to get to Q. That's going to give me a coordinate of -17. Similarly, if I start at P and I go in the forward direction, I'm adding 13 to get to Q. That's going to give me a value of +9. So my two possible coordinates are -17 and 9. Number 19. Point P is between H and G. So H and G are on my ends. P is somewhere in between. If HP is 3 and PG is 5, find the length of the entire thing, HG. Well, we learned using the segment addition postulate that the two pieces of a segment, if it's broken up into pieces, is going to add up, or the sum is going to be the whole thing. So I can write the statement that HP, or the length of HP, plus the length of PG is going to give me the length of the whole thing, HG. Well, since HP is 3, and PG is 5, we can add those together to get 8. So the length of the whole line is 8. Number 20. R is between S and T. So S and T are my ends. R is somewhere in between. RS has a length of 5x. RT has a length of 4x plus 1. And we know the whole thing is 28. Well, the segment addition postulate, just like before, says that the length of the first piece plus the length of the second piece will give us the length of the entire thing. So I can say that 5x plus 4x plus 1 is going to give me the whole length. So my first piece plus my second piece gives me the whole total, the sum. So if I combine my like terms, I get 9x plus 1 equals 28. I'm going to subtract 1 on both sides, and I'm going to get that 9x equals 27. Move this over here. So I have 9x equals 27. I'm going to divide both sides by 9, and I'm going to get that x equals 3. But here's the thing. This problem isn't just asking for the value of x. We also want the value of RS, the length of segment RS, and the length of segment RT. So I can take my value of x and plug it back in over here. So if I do 5 times 3, I'll get a value of 15 here. If I plug in 3 here, 4 times 3 is 12, plus 1 is 13. The first time I did this problem, I made a mistake. And the reason I knew I made a mistake, and you haven't seen me do it, I started over, was these two numbers didn't add up to 28. I knew I had done something wrong. But the reason we know this one's correct is because this is a value of 15, it's a value of 13. Together, they add up to the full total of 28. That's a really good way to check your answer. Okay, number 21. It says that x is the midpoint of segment xy. So here's segment xy. Oh, sorry, segment zy. X is the midpoint. Well, that means x is the exact middle. I can add these tick marks, which means that this side is the exact same length as this side. Well, we know that xz is 3x plus 4, and we know that xy is 2x plus 10. We want the length of zy, the length of the entire thing. Well, because this is a midpoint, we can say that this piece is equal in length to this piece. Their values are the same. Their lengths are the same. So I'm going to say that 3x plus 4 equals 2x plus 10. Let's solve. I'm going to subtract 2x on both sides. So I have 1x left here plus 4 equals 10. Now I'm going to subtract 4 on both sides. And I'm going to get that x equals 6. But we don't just want the value of x, we want the length of the value or the length of the entire thing. So I'm going to plug 6 back in. So I'm going to get 3 times 6 plus 4. That's 18 plus 4, that's 22. Over here I get 2 times 6 plus 10. That's 12 plus 10, which is also 22. That's good. Remember, we're using the word midpoint. That means our two sides should be the exact same length. It reminds us that when we have the midpoint problem, we're going to set our two halves equal. They're the same. So finally, we can say, what's the value of zy? Well, zy is the whole thing, which is 22 plus 22. That gives us a length of 44. Okay, that's the end of page 2. Stay tuned for a video on page 3.